Okay, everybody, we're only going to do one today. And so we have a function here, f, and it's defined over -4 to 3. And the graph consists of 2 quarter circles and then a line segment. And it says that g of x is then the function that's defined by 2x plus the integral from 0 to x of f of t dt. And you're asked to find g of -3, and then find the derivative of g, and then evaluate the derivative at -3. So g of -3 would be 2 times -3 plus the integral from 0 to -3 of f of t dt. Okay, so 2 times -3 is -6, plus, and then the integral from 0 to -3. 0 to -3 would be this area of this quarter circle right there, but realize I'm going backwards. So I have the integral from 0 to -3, but I'm going backwards and it's above, so it's going to be a negative area. So that's going to be negative pi times r, which is 3, squared divided by 4, because it's a quarter circle. And so that's how we end up getting, where are we at here? This -6 minus 9 pi over 4. Then we're asked to find the derivative of g. Okay, so g prime would be the derivative of 2x, which would be 2, plus, and then the derivative of this integral would be what I get when I put my upper limit into my function and chain on the derivative of that upper limit. So that would just be f of x. Derivative of x is just 1. So that's my derivative. You get a point for that. And then we also get a point for putting -3 in and getting the correct value there. So that would be 2 plus f of -3. And what's fantastic about that, folks, is that f of -3 is 0. And so I have 2 plus 0, which is just 2. So you get 3 points. Obviously, you can see how those are allocated. Part B says, determine the x-coordinate of the point where g has an absolute max. Absolute max and mins are where the derivative is equal to 0, so we need to take g's derivative, which is 2 plus f of x. 2 plus f of x, and set that equal to 0. So I'm looking for where f is equal to -2. And I also need to look for where f is undefined. And so if I look on this picture, -2 is down here. And so we can see at this x value right here is where my derivative is equal to 0. Well, the equation of this line, if we went through and found the equation of the line, I'm going to use this point down here. So that would be y plus 3 is equal to my slope, and the slope of that line is going to end up being a rise of 6 and a run of 3, and so that would be a -2 times x minus the x value here, which would be 3. Okay, so cleaning that up, I'll have y plus 3 is equal to -2 times x minus 3, and when I set that, when I put -2 in for my y there, I'm going to take it back over here. So I have -2 plus 3 is equal to -2 times x minus 3. And so this would be a 1. It's equal to -2 times x minus 3. I'm going to divide that off, so that would give me a -1/2 is equal to x minus 3. And when I add my 3 over, that's where I get my 5/2. Okay? But you also can see that I have a couple places where my no, I think we're okay. So I have 5/2 on here, It also said the closed interval, so we've got to talk about -4 and 3, and we want to see what's going on in between these values by plugging them back into the derivative. So let's just take -3. Let's put -3 back into my derivative, so that would be 2 plus f of -3. I found f of -3 was 0, so this would be a positive, so 2 plus 0 is positive. And then somewhere in here, let's just use 3, okay? You can see that 3, my y value down here is -3, so 2 plus -3 is going to give me a negative, and so you can see that I do in fact have a maximum at this point. So the derivative is equal to 0 when f is equal to -2. This occurs at 5/2. The derivative is greater than 0 from -4 to 5/2, and it's less than 0 from 5/2 to 3. Therefore, g has an absolute maximum at x equals 5/2. And so you get a point here for recognizing that you have to set your derivative of g equal to 0. Okay, just state that right there, and you got yourself a point. You have to identify 5/2 and then your justification. Okay. Okay. Let's go to part C. Find all values of x on the interval from -4 to 3 where the graph of g has a point of inflection. Well, you know what? G prime was 2 plus f of x, correct? So g double prime, because I'm going to need to know double prime to get the point of inflection, would just be 0 plus the derivative of f. Okay, so what I need to do is go over to this graph here and figure out where my derivative, or my slopes, are 0 or undefined. So you notice right here, I have a slope being undefined. It's a vertical slope. Right here, I have a slope being undefined. It's going to create some sort of a corner. Okay, and then my derivative is equal to 0 nowhere else because the slopes, that would be where the slopes are equal to 0. So all I really care about here is -3 on my continuum and 0, and let's see what's going on in between. Okay, so from -4 to -3, you can see that my slopes here are all positive. From -3 to 0, again, my slopes are all positive. And then from 0 to 3, my slopes are all negative. And so the only point of inflection, remember, is where it changes sign. You cannot say that -3 is a point of inflection before testing it. And so we have a point of inflection occurring at x equals 0. And so you get a point just for having your correct answer with reason. So x equals 0 because the f prime changes sign, which is g double prime. Okay, and then part D said, find the average rate of change of f on the interval from -4 to 3. Average rate of change, remember, is the slope of the secant line. So I'm talking about the slope of the secant line of f from -4 to 3. So what I need to do here is find f of 3 minus f of -4 all over 3 minus -4. F of 3 is -3. F of -4 was -1, so I'm going to do that +1. All over 3 minus -4 is +7. So that's how I get -2 over +7. However, it's saying, why does this statement not contradict the mean value theorem? Well, if you remember the mean value theorem, the hypothesis stated that your function had to be continuous and differentiable over the interval stated in order for it to work. And you can see here that we're continuous, but we're not differentiable at -3 or at 0. You can see it on your paper anyway. So to apply the mean value theorem, f must be differentiable at each point, and f is not differentiable at -3 and at 0. So it does not contradict the mean value theorem because it doesn't meet the hypothesis. So you have a point here for having your correct average rate of change, and you have a point for the explanation